Well, here we are, chaps. A hell of a lot of work, although it doesn't look like it. I heard mention of Leibniz, that great man, and his kinetic energy experiment, rolling masses down a ramp and then gliding with a pendulum to measure the energy. Well, I thought this would be good to do our 1 mass 2 velocity and a 4 mass 1 velocity test to find if they're the equality. Because momentum would say that a 1 mass times 1 velocity, or let's say a 4 mass times 1 velocity would be 4 units of energy. Well, this is what somebody on the internet who should remain nameless says. But a 1 mass times 2 velocity would only be 2 units of energy, only half the energy, because physics says that they're the same. So it's a bit tricky to film. First things first, as for 12 ounces, should be 1/4 of that, 3 ounces. I've had to, the weight is sandwiched because it's rolling. It's too narrow to roll straight, so I've sandwiched it with this foam, which doesn't add any moment of inertia, but it stabilizes it on its run. I'll try and get the camera in a sort of a position we can see, but it's not perfect, but it's the best I can do. First of all, the 4 mass going 1 velocity. This is my first line. I've measured here, this I didn't explain actually. This baseboard is horizontal, and from there, this is the same height. So as this rolls down, it collides with that mass. They're the same height. So from this height, I've measured, I forget what it was now, to this first line, and then with this, so it's all right. Took a bit of trouble to get it right, you know. And 4 times the height, I've got to line up here to give it twice the velocity. Right, so I do it a few runs. Of course, you can't just put a plank and roll things down because they go all left and right and everywhere. So I've got this little guide rail and a slight angle to keep the weight against it. No friction to worry about, but it's a guide. Right, this is the 4 mass. All we can do is judge roughly how high or how far this bob goes. I've got to try and catch it, otherwise it'll cause havoc in the workshop. To my mind, it's roughly getting towards the end of this wood. Dee 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 dee. Adjustment. Try again. That's a bit better. Twist a bit. Well, we're not aiming to win any prizes for accuracy. We're getting a rough idea of the kinetic energy. Okay, where's it going? Just over this black pad, isn't it? Right, let's try the 1 mass at 2 velocities. I don't know whether you'll be able to see me releasing it. Boom! There you are. That's the problem. Stay still. Hey! You can see how far that went, guys. Yeah. So they're roughly the same. Draft science momentum theory would say that there would be only half the energy in this. But of course they're the same because of the kinetic energy theory. Demonstrated quite nicely there, I think. It doesn't matter whether I've heard some excuse from you know who that whether you're measuring the length of the linear along the ground or the height, which is combined, because you can't have the length without the height. That's a rough idea of how much energy is imparted to the bob visually. It's good enough to see. It's not half the energy, it's roughly the same. Well, I hope that helps a few people that might be being misled along the way. Bye for now.